we're going to start with the most reactive carboxylic acid derivative, which is acid chloride and acid bromide. All right, so if you look at the reactivity rank here, acid chloride and acid bromide is at the top here. All right, and we have like the rest down here. We're going to learn about how to make it first, and then the reaction, what we can do with it. Okay, but just to look ahead when you do a synthesis, it's easier to start with the reactive compound. Let's say start from the top, like at the top of the reactivity rank, and go down in the reactivity rank. For example, if you want to make an amide, it's easier, it's more convenient to start from the top, acid chloride, and then make amide. Or if you want to make an ester, start with acid chloride and make an ester. You will see it later, right? If the reactivity is really close, for example, you want to make an amide and you start with an ester, the yield is not as good. It's easier to start from the high reactive compound and go to lower reactive compound when you do synthesis. Okay. All right. So this is probably going to be the main reaction, especially in synthesis, because all the carboxylic acid derivatives are made from can be made from acid chloride and acid bromide. All right. All right. Start with how to make an acid chloride. Well, we make from carboxylic acid. There are two ways to make an acid chloride. So either thionyl chloride, you have seen this reaction before. First time you saw it in the alcohol chapter, and another one, so oxalyl chloride, and the mechanism are really similar. Okay, these two reactions are very spontaneous. Do you know why though? Well, the reaction produces gas. If you use thionyl chloride, you make sulfur dioxide, and the equilibrium go really forward. And it's only because when a reaction produces gas bubble out of reaction, so it won't go backwards. So basically, this reaction is actually a one-way reaction. Okay, if you use oxalyl chloride, you make two gases, so carbon dioxide and carbon monoxide. All right. Now the mechanism. So for thionyl chloride, we have talked about earlier. All right. What I want to point out is take a look at the first step right here. So you got two options, so two nucleophilic center, right? And we're going to use the sp2 oxygen because this guy have high electron density, and it's only because the two lone pair are localized. Okay, so this oxygen attack the thionyl chloride, and then everything go from there. All right, and you get the excellent leaving group here, and at the end, so take this guy, go further, you should make sulfur dioxide at the end. All right, so we talked about this mechanism before, so I'm just going to skip it. Another mechanism when you use oxalyl chloride, really similar. I'll have you draw at home, so make sure you draw. All right, make sure you draw the mechanism. I can ask you on the mechanism, let's say on the quiz. All right, okay, all right, that's pretty much it. That's how you make acid chloride. Now we're going to move on to what can we do with acid chloride. Okay,